Hello, Integrated Mathland. Welcome to Module 2, Topic 2, Lesson number 1. And we're doing day 1 today. We're just going to do the first half of the lesson today, and we'll worry about the second half next time. So a lot of this is going to feel like review to you, and that's totally okay because we're not really doing anything new. We might make it a little more complicated. We might make you work for it a little bit more, but there's not really anything much that's new today. So we are solving linear equations, and what we're really going to focus on in this activity 1.1 on page M2-99 in your book is we're going to focus on using properties to justify our solutions. It basically means that we have to explain how we got our answer. Really. Yeah, we show our work, but we have to explain our work as we go, and it's actually not that bad. So if you recall all of those properties of equality, you recall that the properties of equality are rules that allow you to maintain balance and rewrite equations to isolate the variables. So the idea is that when you solve an equation, that equal sign is like a big dividing line, right? It's like a big dividing line. And what you do to one side, you must do to the other. But we have names for these things. So for example, if you add the same thing to both sides, we call that, I'm gonna bring back my arrow here for a little bit, come back. We call that the addition property of equality. That just means if A equals B and I add C to A, then I also have to add C to B. So if I add C to one side of my equal sign, I have to add C to the other side of the equal sign. If I subtract the same thing from both sides, we call that the subtraction property of equality. So if A equals B, then A minus C should equal B minus C. If I subtract C from one side of the equal sign, I must do it to the other side of the equal sign. Remember that equal sign is like a big dividing line right down the middle of your equation. If I multiply both sides by the same thing, we call that the multiplication property of equality. So if A equals B, then A times C should equal B times C. So if I multiply by C on one side, I should do it to the other as well. And last but not least, division property of equality. If I divide by the same thing on both sides, it's called the division property of equality. Now, do be careful with this one, because notice that whatever you're dividing by can't equal 0. Dividing by 0 is bad. No. 0 on top, okay. 0 on the bottom, that's bad. So if A equals B and C does not equal 0, then A divided by C should equal B divided by C. If I divide by C on one side, I must divide by C on the other side of that equal sign, that dividing line. So in our getting started activity that we all did together, you came up with a new equation, right? We started with x equals 2, and then you created a whole new equation from that. So Sarah and Ethan did the same getting started activity that we did. And Sarah, when she did all of her bits, got the equation negative 3x plus 14 equals 18 minus 5x. And Ethan, when he followed the steps on the getting started activity, got a very different looking equation that looks like 2x equals 5 minus 1/2 x. So they both followed the steps that we followed on the getting started activity, but this is what their equations look like. Looks very different than the equation that I came up with on the getting started activity. And it probably looks really different than the equation you came up with on the getting started activity as well, because there were just infinite possibilities, right? So here's what we're going to do. We're going to use two different methods to verify that both equations will give us x equals 2. And we're going to use two different strategies to help us do that. So the first strategy is substitution. That just means, let me bring my pen up here, make this a little easier to use. Substitution just means, hey guys, guess what? I know that x equals 2. So that means we're going to substitute in. So for Sarah's equation, this guy right here, you're going to substitute in a 2 for x. And you'll do the same thing for Ethan. So go ahead, hit pause, substitute in that x equals 2, and then hit play when you're ready to check your work. All right, guys. How'd you do? So I went ahead and I plugged in a 2. So I was like, okay, x equals 2. So that means instead of negative 3x, I can do negative 3 times 2. And instead of negative 5x, I can do negative 5 times 2. So I plugged those in. And then I started to clean up a little bit. I know negative 3 times 2 is a negative 6. I know negative 5 times 2 is a negative 10. So negative 6 plus 14 equals 18 minus 10. So the 14 and 18 haven't changed yet. And of course, we can take this further. Negative 6 plus 14, you're welcome to use a calculator if you need to. Totally fine. Negative 6 plus 14 gives me 8, and 18 minus 10 gives me 8. Oh, look at that. 8 equals 8. We know that 8 equals 8. 8 definitely equals 8. So x equals 2 is a solution. That worked quite well. We substituted in and we got 8 equals 8. So all is good and right in our world. Wonderful. Did you do Ethan's equation as well? If not, now might be a good time to hit pause and to plug in for Ethan's equation if you haven't already. If you've already plugged in for Ethan's equation though, I'm going to go ahead and keep going. So again, instead of 2x, I know that x equals 2, so I can do 2 times 2. And instead of negative 1/2 x, I know that x equals 2, so negative 1/2 times 2. So I just plugged those in there. And then I cleaned up a little bit. 2 times 2 is 4. Of course, the equal sign's still there. The 5 is still there. And now here's where it gets interesting. Negative 1/2 times 2. Well, I know half of 2 is 1. So that becomes a minus 1. That's terribly convenient, isn't it? So it looks like this side already sorted itself out, but we need to finish off the right side. Pretty easy. 5 minus 1 gives us 4. Hooray. And so, yeah, 4 does equal 4. So good. That means x equals 2 is a solution. We ended up with both sides being the same. That's a good sign that it's a solution. So this was our substitution strategy. Plug it in and make sure both sides give us the same thing. Boom, it's a solution. Hooray. Now, a little further though, let's actually use our properties of equality. So all those properties we were just talking about, how you add the same thing to both sides, or subtract the same thing to both sides, or multiply the same thing to both sides, use that strategy to find out what x equals. So we're not plugging in this time. This time you're actually going to kill numbers off on each side in order to solve it and see what you get from your answer. So we'll start with Sarah's equation and then move on to Ethan's equation. Go ahead and hit pause to work these out and then hit play when you're ready to check your work. All right, how you doing? I'm bringing up my pen here. I don't like that negative 3x. It's kind of freaking me out a little bit. So I'm going to use the addition property of equality. And I'm going to, oops, that's not what I want to have happen. I'm going to use my pen this time. And so I'm going to add 3x to both sides. I am lining it up with the like terms just to make it a little easier to work out. And it looks like, and I'm going to change colors a lot too to make it easier. So these guys die off, which is why we did it. And we have 14 equals 18, and a negative 5x plus 3x, and you're welcome to use a calculator if you need to. Negative 5 and a positive 3 gives me negative 2x. Hooray! So this is all fine and good and dandy and great. However, we are not done yet. I need to get x totally alone. We're solving it just like we did in the warm-ups, So I'm going to go ahead and subtract 18 from both sides. So I'm using that subtraction property once again. And again, some people find it helpful to have like a big line there for their equal sign, and that's cool, that's fine. There my other color. So the 18s die off. That was a positive 18, so I'm going to subtract 18 to kill it. 14 minus 18 is a negative 4, and that equals a negative 2x. Do watch those negatives. They're so tricky. Notice that was a positive 18, so I had to subtract 18 to get rid of it. And one last step then. We're so close. We're almost there. Let's get x alone. I'm going to go ahead and divide by a negative 2, divide by a negative 2. Ooh, which means I'm using the division property of equality because I'm dividing by a negative 2 on both sides. We're almost there. We're so close. We're so close. So the negative 2's cancel out, which is why we did it. So we just have an x over here equals negative 4 divided by negative 2 gives me, dun da da, a positive 2. Hooray! So yeah, it looks like Sarah's solution is x equals 2. What about Ethan? Did you work out Ethan's? I'm going to erase this real quick just because I've got other junk under here. Goodbye. I did it all like this. I made it all pretty. Isn't that pretty? So let's talk about Ethan's equation. If you haven't worked out Ethan's equation yet, go ahead and hit pause. Work that out. Otherwise, if you have, go ahead and keep us playing. We'll keep it moving forward. So again, I know a lot of students like to put like a big bar down the middle. I think some of you guys were calling it the box method a few weeks ago, if I recall. So if we'll put a big big line down the middle. And let's go ahead and see what we can do here. The first thing I want to do, this is a mess. This is a hot mess. I don't like that negative 1/2 x. So I'm going to go ahead and add 1/2 x to both sides, add 1/2 x to both sides, just so I can kill off that negative 1/2 x, because I don't know, I don't like negatives. They kind of freak me out a little bit. So I still have the equal sign. I still have the 5. Hooray. Now this is where it gets tricky, but not impossible. 2x plus 1/2 x. Well, that's 2.5 x. To make it easier though, instead of writing 2.5 x, I'm gonna spare myself some grief, and I'm gonna write it as 2.5 x. I just turned it into a decimal. You don't have to. You could have left it as 2.5 x. That would have been fine, but I just find this easier to work with. Wow, and that means we're actually really close. So I use the addition property of equality because I added 1/2 x to both sides. And now I'm ready to finish this off with a little division property of equality. Sorry. So I'm going to divide both sides by 2.5. So that kills off these 2.5. So division property of equality at work here. That leaves me with x equals, and if you grab a calculator, which I would recommend doing for some of these, 5 divided by 2.5. If you grab a calculator, you'll find that 5 divided by 2.5 is 2. Yes, it is. Hooray! So I know a lot of you guys like this box method. I like the box method too. I'm not going to lie, but I'm just going to warn you that your book tends to write it like this. Let me erase all that ink off of there. Your book tends to write it like this. They tend to write it out like horizontally. I don't like that method as much. I like the box method a lot better. But I mean, they both work. They both get the job done. They both get you where you need to be. So here we had to do some addition property of equality, some subtraction property of equality, and some division property of equality. Over here, we did some addition property of equalities and some division property of equality. Now, of course, these are not the only properties. These are the easy ones, right? If you add something to both sides, subtract something to both sides, divide by both sides, multiply by both sides, those are properties of equalities. But there are also some other basic properties that you are already familiar with, but we just want to make sure that we remember them so that we can use them to justify our steps when solving equations. And justifying our steps just means we're explaining what we did. We're saying we did this because of this property. This was because of this property. This was because of this property. That's all we're doing here. So these number properties for all numbers A, B, and C, what this means for us is that for the commutative property just means A plus B equals B plus A. If I do 5 plus 2, it's the same thing as 2 plus 5, right? Commutative property applies to addition, but it also applies to multiplication. A times B equals B times A, right? If I do 2 times 5, it's the same thing as 5 times 2. It doesn't matter. With addition and multiplication only, it's only ones that commutative property applies to. These are the only ones where you can switch the order and it's okay. Same thing with associative property. It only applies to addition and multiplication. So associative property means that if I have A plus B plus C, and notice how my parentheses here indicate I'm supposed to add B and C first. But because all three of them are being added, it means that I could add A and B first instead if I wanted to. Because we just said from commutative property that the order doesn't matter. And associative property says the same thing for addition and multiplication. So if I have A times BC it's equal to AB times C. It doesn't matter if I multiply B and C first or A and B first. If all three of them have to be multiplied, they give me the same answer. Last but not least, one of the big ones that we use a lot, we use it so much, is distributive property. So if I have A times the sum of B and C, then it equals AB plus AC. And that just means we distribute, we often write it like this when we're doing the work. We're like A times B, A times B equals A times C. So this is just one of the ways that we write it. But this is distributive property. It's a way that we can get rid of those parentheses, that I can take the guy outside and just multiply by each term on the inside, each piece on the inside, and then the parentheses go away. Makes life a little bit better, a little bit easier. So you've used these before, particularly distributive property. I know we've used it a lot. So here's what's going to happen. What we're going to do now on number 2, and there's several of these. You've got A, B, and C. You've got 3 of these to work through. Here's what I need you to do. You're going to solve these equations. You know how to solve equations. We were doing these in the warm-up. We just did a few of these just now. No big deal. But now you also need to write alongside it. You need to write the property that justifies the step. Okay, so one of our properties of equality, whether it's addition property of equality, subtraction property of equality, multiplication property of equality, division property of equality, did you use commutative property? Did you use associative property? Did you use distributive property? Which one of these properties did you use? And that's all we're looking for. So you're going to solve this, but as you do each step, right next to it, you need to write the property that you used for that step, okay? So go ahead, hit pause, work these out, and then hit play, all 3 of them, A, B, and C, work these out, and then hit pause to work them out, hit play when you're ready to check your work. All right. You guys do seem to like the box method. I like the box method too. So I'm going to be like, just draw a big old line and be like, dude, make a big old line here. Make things easier. All right. What do I want to do first? Well, I see that I have X's on both sides. So I'm going to kill one of my X's here. I'm going to go ahead and kill the 24X. Since that is a positive 24X, I'm going to go ahead and subtract that 24X, but if you do it to one side, you must do it to the other. Which means right off the bat here, people, we've used subtraction property of equality. Oh my goodness, it takes me longer to write out these properties than to do it. So subtraction property of equality. And then I clean up. 24X minus 24X is 0. It's dead. That's why we did it. So that leaves me with a positive 7 equals negative 4X minus 24X. They're both negative. So that gives me a negative 28X. And let's do the next thing then. Need to get X all alone. And it's being multiplied by that negative 28. So we undo multiplication with division. So we'll divide by a negative 28. But if you do it to one side, you must do it to the other, which means you know what property we just used, right? I just divided on both sides. This is the division property of equality. All right, we gotta finish this off then. So we divided negative 28 by negative 28. That means those will cancel out, which is why we did it. We get X equals, now I do want to simplify this because I get 7 over negative 28. But I do know that 7 goes into 28. So that means I can I can simplify this a little bit just by dividing both these by 7. So divide by 7. That's a terrible way of writing it. 7 divided by 7 is, of course, 1. Negative 28 divided by 7 is a negative 4. So it looks like x is actually negative 1/4 if we simplify our fractions all the way down like we're supposed to, because we're good like that. Nice work. Hope that's what you did, or at least something similar to it. And now, again, you may have used different methods. I am going to warn you, you may have solved this differently than I did, but still got the right answer. But it may, of course, change the properties that you were using. So there's not just one way of solving these. And we'll explore that a little bit more later on. I'm going to go ahead and erase the ink off the slide just because it's a mess. So here's the linear method. They subtracted 24 from both sides, divided by 28, negative 28 on both sides. There it is. Theirs looks prettier than mine, but I like my box method. How'd you do on part B? If you haven't done part B yet, you might want to pause it and work it out and then check your stuff. But if you have, we'll go ahead and keep letting this play, keep moving forward. So the first thing I notice is I don't like these parentheses. So I'm going to distribute that 3. So 3 times 2x, 3 times 2x gives me 6x. 3 times 1 gives me a positive 3. So I'm just going to rewrite that over here. Ooh, which means, guys, which means I distributed that 3. We just used the distributive property. Distributive property. Oh, yeah. All right, so that looks much better already using distributive property. I don't like that I've got all of these x's on both sides. I want x to just be on one side. So I'm going to kill one of these x's. I think today I'm going to kill the negative 4x. Because that is a positive 4x, I'm going to subtract 4x. Ooh, and for those of you that sorry, I forgot my line for my box. I'm going to subtract 4x. And of course, if we do it to one side, we must do it to the other. So I'm going to subtract 4x over here as well. Ooh, which means we just used the subtraction property of equality. I'm subtracting on both sides. So subtraction property of equality. Boom. All right, so 4x minus 4x cancels out. That's why we did it. Got my equal sign. There's still a 6 hanging out over here. 6x minus 4x leaves me only 2 x's. And there's still a plus 3. All right, this is looking pretty good. Next thing, to get that x alone, that 2 is kind of stuck to it, so I'm going to deal with that plus 3, that dangly guy first. So that's a plus 3. I'm going to subtract 3 in order to get rid of it, which means, since I'm doing that to both sides, once again, I just use the subtraction property. Oh man, my pen is going funky today, of equality. Sorry for the weird moments on my pen. It's all good. It's all good. All good things, all good things. So 6 minus 3, of course, gives us 3. 3 minus 3 is 0. That's why we did it, right? We were trying to kill it off. We wanted it gone. So that leaves me with 2x. Ooh, we're so close. We're almost there. So last thing I need to do is get that x alone, and it's being multiplied by a 2. I undo multiplication with division. So I'm going to divide by 2, which means we just use the division property of equality. Ooh. And of course, the 2's cancel out. That's why we did it. And now we have x equals, and you could leave it as 3/2 if you wanted to, or if you would like it as a decimal better, you could also do 3 divided by 2 on your calculator, and you'd find you get 1.5. Either answer is fine. Both are correct. Both do the job. Totally fine. Ooh, I like that box method. I really do. Now, of course, I'm going to erase this because I want to show you what the book did. So the book did the same thing. They distributed first, distributive property, and then they subtracted 4x from both sides, so subtraction of property of equality. And then that left us with 2x plus 3 equals 6. So we got 2. And then we subtracted 3 from both sides, giving us a subtraction property of equality again. And divided by 2 on both sides, giving us the division property of equality for an answer of 3/2. Or, like I said, if you wanted to, you could have written your answer as 1.5. Either way is fine. Last one, part C. How'd you do on this one? Or have you not done it yet? If you haven't done it yet, hit pause. I don't want to ruin it for you. So if you haven't done it yet, hit pause, work it out. Otherwise, I'm going to keep on going here. There was some weird stuff going on the right side here, right, with these parentheses, but there was nothing being multiplied, so I couldn't really do distributive property. But it did seem like there was some other properties that had some parentheses and some things going on. So I'm going to mess with this a little bit. You may not have done all these steps. That's okay. I'm going to show you what I did. So first of all, I want that 1 and that 2 to get together somehow. So the first thing I did is I swapped these guys. Instead of 2x plus 1, I rewrote it as 1 plus 2x. And I'm allowed to do that with addition. I'm allowed to swap them. You remember which property it was? You may have to go back and look. Do you remember what property said I could do that? The commutative property. Yeah, it said I could do that. The other thing, though, is these are all being added, all 3 of these, but I can't really add the 1 and the 2x because they're not like terms. However, I could add the 2 and the 1. So that means if I did 2 plus 1 first instead of 1 plus 2x, which one said I could shift that? I believe that was the associative property that said I could shift that over if I wanted to. So I am. And of course, this makes things better because 2 plus 1 is, well, 3. And already things are looking much, much, much better for us. And now we can go to some of our properties of equality because I want to get rid of one of these x's. I only want x on one side. I don't want x on both sides. And just to help me out, again, I'm going to draw my box here. I'm going to get rid of that that 1/2 x because I don't know, fractions. They bother me. It's a thing. So we'll do our 1/2 x. That's a positive 1/2 x. So I'm going to subtract 1/2 x. And of course, if we do it to one side, we must do it to the other. If I'm subtracting from both sides, that is the subtraction property of equality. Ooh. Oh my goodness. All right, so 1/2 x minus 1/2. Oh, that should have an x on it. Oh my goodness. Slackness, Scott. That was slack. You got to take it all with you. So 1/2 x minus 1/2 x is nothing. It kills itself off. That's why we did it. But I still have a -6. I still have an equal sign. I still have a 3. And now we got to work this out over here. 2x minus 1/2 x. Well, 2 minus 1/2 is 1.5. But to make it easier, I'm going to write that as 1.5x. You could write it as 1.5x. That would be okay too. It just starts to look funny. So I'm going to leave it as 1.5x. And always, if you don't believe me, you can use a calculator to check these things. I'm pretty good about that. I want to get the x alone. The 1.5 is a little too close for comfort. So let's deal with that 3 first. I think it's better to deal with the 3. That's a positive 3, so I'm going to go ahead and subtract 3. You do it to one side, you must do it to the other, which means this is the subtraction property of equality. Of equality. Oh, yeah. And then we got to clean up a little bit, or a lot of it. -6 minus 3 is a -9. Your calculator can confirm that for you if needed. Those are dead. 3 minus 3, it's gone. That's why we did it. And we still have a positive 1.5x. One last step then. We are so close. I need x to be totally alone, but it's being multiplied by 1.5. So I'm going to go ahead and divide by 1.5. And if you do it to one side, you must do it to the other. Ooh, which means this is the division property of equality. It is. Division property of equality. Yeah. Division property of equality. There's a reason why we did this. Ooh, I need my calculator. I have my calculator. So -9 divided by 1.5. Well, I do know that it's going to be a negative, whatever it is, because negative divided by positive is a negative. But I'm going to use my calculator and do 9 divided by 1.5, and it tells me the answer is 6. Okay, cool. These cancel out, so I just am left with x. Hooray! Hooray! Yeah, all right. We got there. You know what? I like my box method, but again, I just want to show you that the format the book uses, they did the same thing we did. The book did the same thing we did, but I want you to see that format so that you can get more used to it. So they did the same thing we did, subtracted 1/2 x from both sides using the subtraction property of equality. Subtracted 3 from both sides, again, subtraction property of equality. And then last but not least, divided by 1.5 for the division property of equality. And again, got an answer of -6. I didn't put a negative on my 6, did I? It's a -6. Sorry. All right, so this is one of the things this is what you're going to be doing on a lot of your homework assignments, is you're going to be solving equations and your homework problems, but you also have to write the reason for why you did what you did. So that's going to be super important. Now, to help you get more familiar with these properties, I do have just a few more problems that I want you to take a look at. So let's go over to we're still on page 100, but let's go over to number 3. And here we have 2 different solution strategies. I would like you to compare the solution strategies used by Kaylee and Destiny. Notice they started off with the exact same equation. They got the exact same answer, but they definitely used different methods to get there. So what do you notice about the properties each student used? What I would recommend doing is just off to the side, write down what properties did Kaylee use and write down what properties Destiny used, and then tell me what you notice. So go ahead and hit pause to jot down some notes here and your thoughts on this, and then hit play when you're ready to check your work. All right, so I started off with Kaylee's solution over here, and I'm looking at what she used. It looks like she got rid of those parentheses first. She distributed that 4, so that's definitely some distributive property. It looks like she then kind of did like a twofer on this, right? It looks like she then subtracted 8x on both sides, but at the same time, she also subtracted 8 on both sides. So she went like wild with the subtraction property there. So it's definitely the subtraction property of equality. She went kind of crazy with it. And last but not least, it looks like the last thing she did to get x alone was dividing by 4. So she did that little division by 4, which is the division property of equality. Good for you, Kaylee. Good for you. Now, Destiny used a different method. It's not the first one that would have come to my mind, but it works. So Destiny didn't like that 4 being multiplied outside, so she divided both sides by 4. Destiny, instead of distributing the 4, divided it out. So she used the division property of equality. Again, not the first method that pops into my head, but it's a great method. Pardon me, I won't deny it's a good one. So these actually, let me use my pen here. So these actually cancel out. So you just get 3x plus 2 over here. And you have to divide both of these by 4. So 8x divided by 4 is 2x. And 4 divided by 4 is 1. And look how nice that is. And then it looks like she went crazy, also went crazy with subtraction property, because it looks like she subtracted 2x from both sides and at the same time subtracted 2 from both sides. Man, these gals are serious about their subtraction property of equality. They are not messing around. So it's interesting because they both used division property and subtraction property, but not in the same order. And in fact, you'll notice Destiny didn't even use distributive property. Oh, and I misspelled Destiny's name. I'm sorry, Destiny. Hang on. I'm going to fix that. I can fix it. I'm going to fix it. Maybe I'll fix it. I'm not fixing it today. Okay, never mind. So Kaylee started with the distributive property, but Destiny started with the division property of equality. So they started out differently, but they both got to where they needed to be. They both used division property. They both use the subtraction property of equality. It works. It does the job. They both got there, and that's okay. They both justified their steps. So this is what I was telling you guys earlier when I said that oftentimes there's more than one way to solve these. There is. Both of these pick gals solved the exact same equation. They both got the exact same answer. They both justified. They both gave their steps. They both did it correctly. They just did it differently, and that's okay. So last little thing, we have the talk the talk. So we're going to jump a few pages over to page 104, M2-104. We're going to go to the talk the talk. And you have two problems there. Now, the first problem, I would like you to write the property that justifies each step to solve the given equation. So they actually solved it for you. I want you to take a close look and tell me what properties they used. All right, go ahead and hit pause, write down the properties that they used, and then hit play when you're ready to check your work. All right, I noticed the first thing I noticed, I'm gonna grab my red pen so you can see it a little better. I noticed that they got rid of parentheses. You notice there was like some serious distribution going on here, like boom, boom. Yeah, there was a whole bunch of distributive property happening. A third of 6 is 2. Negative, a third of 21 is 7. They watch the negatives and positives. Watch out for that. 5 times x is 5x. 5 times 1 is 5. Just watch the negatives. Always a good thing. Now let's see, what changed from here to here? I noticed that there's like a plus 5x that appeared on both sides. I'm pretty sure that's the addition property of equality. And of course, that cancels those guys out. Negative 2x plus 5x gives me 3x. So that's good. What's happening now? Ooh, I noticed that a minus 7 appeared on both sides. So that looks like subtraction property of equality, most definitely. 7 minus 7 kills it off, so we just have a 3x. Negative 5 and a negative 7 gave us a negative 12. Oh, and how'd they finish this off? They finished it off by dividing. Yes, they did. Division property of equality. So they divided both sides by 3. Those 3's canceled out, and negative 12 divided by 3 is a negative 4. Hooray! So we didn't actually have to solve it. We just needed to write down the steps of what they did. We're basically writing down their steps. They used distributive property. They used addition property of equality. They used subtraction property of equality. They used division property of equality. Always good things. Last problem, number 2. This time, I do want you to solve the equation, but I don't want you to just do anything. You need to solve the equation using the justification given for each step. So take a look at what they have over here. They kind of told you what step to use. They told you what step to use. They did. The first step's a tricky one, but I think you'll be okay with the others. So use the steps that they gave you. Use those justifications for each step. Use those like directions. They're telling you what to do to solve the equation. So go ahead, hit pause, work this out, solve the equation. You know what the answer is supposed to be. They gave it to you at the bottom, but solve the equation using the steps that they gave you. So hit pause to work that out. Hit play when you're ready to check your work. So the first step is the multiplication property of equality. Why the multiplication property of equality? Well, because I noticed I don't like fractions. I don't like fractions. And there is this stuff being divided by 3, and I don't like that. So we're going to go ahead and we're going to multiply both sides by 3 for the multiplication property of equality. So this whole thing, that 5x plus 7, is going to get multiplied by 3. This whole beast over here, and it is a beast, is also going to get multiplied by 3. Now, it looks scary, but it actually makes things better. It does. Watch, watch, watch. So now they said to use distributive property. We kind of know that one. So if we use distributive property, and I'm going to pull my pen up over here. So 3 times 5x. Oh, goodness gracious. What happened there? What happened? Oh, that was terrible. I'm going to write it better. So we'll do 3 times 5x and 3 times 7. That's easy enough, right? 3 times 5x is 15x. 15x plus 21. And then we'll distribute the 3. So watch what happens here. When I distribute the 3 over here, it kills off that bottom 3. The 3 on top, 3 on bottom, they cancel out. So we just have negative 15x minus 1. Same thing happens over here, though. If you do 3 times 4/3, the 3's will cancel out, and you just have a plus 4. Hooray for distributive property. All right, so there's the distributive property in use. The next one they said is the associative property. That's the one where they said it doesn't matter if you add these guys first or add those guys first, right? So I think the deal is this guy has no parentheses, so he's fine. 15x plus 21, he's all right. But let's look at this. Instead of doing negative 15x and a negative 1 first, instead we'll do negative 1 plus 4 first. Oh, that makes things better, doesn't it? And in fact, we know it makes things better because we know that negative 4 plus 1 is just 3. So now negative 15x plus 3. Yay! I'm going to go ahead and erase these. I think you get the idea here. All right. And we said, of course, we were just saying that this is going to give us a 3. So we're like, dude, you cool. We're a 3 now. Hey. All right. All right. Says to use subtraction property of equality. There are a lot of things I could subtract here. How about if we subtract this 21? Let's kill off the 21. Instead of a plus 21, let's subtract 21. But if you do it to one side, you must do it to the other. So I'm going to subtract 21 on both sides. That's our subtraction property of equality. So those die off, which is what we wanted. And of course, 3 minus 21 is actually a negative 18. The next thing it says is the addition property of equality. I don't like that there's x's on both sides, so let's get rid of that negative 15x by adding 15x. And so we'll add 15x. If you do it to one side, you must do it to the other. These cancel out, which is why we did it. And that means that 15x plus 15x, that gives us a 30x, right? So we now have 30x equals negative 18. Sorry that this is messy, but they didn't give me a lot of space on these things. Last but not least, it does say division property of equality. Oh yeah, to get the x alone, you're going to have to divide both sides by 30. Yeah, we'll divide both sides by 30. And of course, there's a reason we do that, and that's because those guys will cancel out. So negative 18 divided by 30. Ooh, that simplifies down because I can divide both of those by 6, right? I can be like, divide by 6, divide by 6. Always simplify your fractions whenever you can. Negative 18 divided by 6 is a negative 3, and 30 divided by 6 is 5. Wow, look at that. So we used the properties that they gave us to help us work this out. All right, well done us. Good job us. All right, guys, as always, I hope you found this helpful. I hope you found this useful. If you've got questions or concerns, please let me know. You can stick around after class. You can come see me during office hours. There's so many options. Talk to me and I can help you out. Otherwise, I'll see you later. Bye.